Okay, so a little bit of review. When I rewrite this log, remember, do your loop. So if I rewrote that, what would that be? Meg, you got a question?
Yeah, I don't have the notes. I can't copy them.
Just, yeah, OneNote's been messy with me, so we'll just have to copy it over from the content library.
I tried doing that, it didn't work.
Still didn't work?
Yeah.
Okay, so what would that be rewritten as? Jessica, what would that be rewritten as? Yep. Remember, just follow your loop, right? Start with the base, go to the other side of the equal sign, that's your exponent. The argument is what it's equal to. Now, evaluating is, now remember, these logs, if you plug it into a calculator, it's just a number, right? Okay. When you don't see a base, what is it? 10. Okay, and if we're evaluating, we can set it equal to x. Rewrite, if I rewrote this one then, Maria? 1,000. Same thing in, okay, what power, taking 10 to what power equals 1,000? 10 squared is 100, right? 100 times 10 is 1,000. So in this case, x is equal to 3. Now remember, one way you can do this, we got that, rewriting them so they have the same base, correct? 10 to the x, 10 cubed is 1,000. And then once you have the same base, the exponent should be the same as well, right? So you can set them equal to each other, then solve from there. And in this case, you don't have any more steps to solve it. Okay, so set it equal to x. We have 16. The x equals 1/2. Now remember, if you're going from a whole number base to a fraction, it's going to have to be negative, right? We're going from 16 to 2. So that's going to have to be a fraction as well. Okay? So, what I would do, this is definitely one where I would rewrite the bases. Okay, you see 2, right? Get them so they have a base of 2. 2 to what power is 16? Squared is 4, 2 is 8, 2 to the 4th is 16, right? So 2 to the 4, then you take that to the x power. And that would be 1 over 2 to the 1st. Power to a power, you got 2 to the 4x. Bringing that 2 to the top would make it 2 to the negative 1st, correct? Now my bases are the same. Set your exponents equal to each other. Solve from there. Negative 1/4. So when you type log base 16 of 1/2 into the calculator, all it's thinking in the calculator is that it's negative 1/4. Yeah, there's evaluating. Questions on those? That was Tuesday, right? Evaluating and rewriting. Okay, now today we're going to find inverses. Okay, the process of finding that inverse is still the same. Flip-flopping x and y, solve for y. And then having your proper notation. Then we're going to graph log functions. Now, what's the inverse operation of exponents? Logs, right? Okay, so it's going to look like the inverse. Okay, so exponential, we have a horizontal asymptote, right? So what type of asymptote do you think we're going to have on logarithms? Vertical. Okay? So then the parent function, in this case, y is equal to log base b of x minus h plus k. Now, if you have an h value, it will always be in parentheses. Okay, so like when I say log base 10 of x plus 2, is that your h or k value? This is the common mistake. In this case, your h value is 0, and then the k value is 2. Now, if I was to say log base 10 of x plus 2 in parentheses, that is where your hk value is negative 2, 0. Because again, we always think opposite of h, or opposite of x, right? Opposite of what we're seeing, and then what we see with k. So look for the parentheses. That's where your h value will be. You guys see the difference there? Alright. And then again, parent function. These will have vertical asymptotes. It's going to look similar to those exponential growth and decay functions. It's just that you get that vertical asymptote, and it's either going to be going up and to the right, or down and to the left, to the right. Alright, we just reviewed. You guys want to go through any of those? Like that top left one, maybe? Okay, so, can you do anything right there? In the way it is? Okay, so again, if you're stuck in one form, what should you do? You write it, right? Okay. So, log base 10 of, we don't know what it's equal to, right? So x equals log 4. Everyone see how I got that? Set equal to x, rewrite it into log form. There's a log base 10 of x is equal to log 4. And when I say log 4, what's the base? Spainer? 10. So if I got log 10 on both sides, shouldn't the argument be the same? They got the same base, right? Arguments should be the same if they're equal. So in this case, x equals 4. Right, so if you're stuck in one form, make sure to rewrite. It's going to be a lot easier to see in one form. Okay. Bases are the same, therefore the arguments should be the same, so you set them equal to each other. In this case, it's just 4. Okay, so 10 to the log 4 is just 4. Can you guys tell me what that is just off the top of your head, without even having to rewrite? You're thinking 5 to what power is 125, right? 5 cubed is 125? Again, I don't know what that is, so I'm going to set it equal to x and rewrite. 4 to the x is equal to 1/2. I'm seeing 2 there, and I can write 4 with a base of 2, can't I? Notice, 2 squared to the x, that's going to be just 2 to the 2x. And when I got 1/2, that's 2 to the negative first, correct? So set, now that I have the bases the same, setting those exponents equal to each other. Solving for x. Okay, so log 4 of 1/2 is negative 1/2. Again, set it equal to x. Rewrite. 4 to the x is equal to 16 to the x. 2 to the 2x. We said 2 to the 4th is 16, right? So 2 to the 4x. So 2x is equal to 4x. It's kind of a weird one, isn't it? Still solve it the same. Get everything to one side. Subtract 2x on this side. 0 equals 2x. Divide by 2. X would have to be 0. That's a weird one. Alright, questions on that review page at all? Big thing, rewrite, correct? Rewrite, rewrite, rewrite. Alright, finding inverses now. Again, when we found inverses last chapter, right? What's the first step? Find an inverse. Switch x and y. And I got x is equal to log base 8 of y. And then our goal is to solve for y, correct? What do you think we need to do? So in order to isolate y. Solving, any ideas? So remember now, inverse operations, right? What's the inverse of logs? Exponents, right? What does rewriting do? Gets us into exponent form, right? So, when you're solving for y in this case, rewrite. When I rewrite this, 8 to the x is equal to y, correct? Did I solve for y? So and then the last thing for an inverse, Ethan, what do we need to make sure to have? It's an inverse. You gotta tell me that it's an inverse, right? So we have to have the proper notation, right? So f inverse of x is equal to that 8 to the x. So flip x and y, solve for y, and in this case it's typically going to be just rewriting and then have that proper notation. Now, on B, what's ln? What's natural log again? Anybody? Natural log is just log base e, correct? So if you have a hard time seeing it, just rewrite it as log base e. And then, Jessica, your first step, flip x and y. And then solve for y, right? Drew, what was that step to help us solve for y then?
I don't know.
What did we do over here? Y was in the argument, right? What did we do?
I have no idea.
Rewrite it, right? Into exponential form. That's going to say e to the x is equal to, the argument was y minus 3, correct? So y minus 3. But now we got one more step, correct? I got to add 3 to both sides, so then e to the x plus 3 is equal to y. Aubrey, what's that final step I need to make sure to take?
X.
F inverse of x, yep. It's a big thing. Have you noticed? A lot of rewriting. So again, make sure you can rewrite. Questions on inverses at all? And the process is the same, right? It's just a matter of isolating y's a little bit different in this case compared to what we've done. Okay, so graphing now. Okay, the blue ones, there's our exponential growth and decay. What do you notice about the red, which is our logs? Remember inverses, when we graphed them, they reflected over that line of y equals x, correct? The blue and red there, does that look like it's reflected over that line of y equals x? Yep. Same thing here. Okay. That is, the red is our functions, or our graphs for logs. And again, now exponentials had horizontal asymptotes, logs will have a vertical asymptote. Okay, so again, we went over this general form. Still see that h and k. We're not going to worry about an a value. Okay, we just got to get that h and k, and then our table is going to be a little bit different this time around. And we got that vertical asymptote at h now. Okay. And domain, we're going to have a restricted domain and no restriction on our range in this case. Okay. So graph the function f of x equals 3x, log base 3 of x. What is our hk in this case? Mara, hk in this case? 0, 0. Matt, what type of asymptote did we say we'll have with logs? Vertical. We had horizontal with exponential. Okay. Now, in these cases, all we're going to do is x and f of x. Okay, or you can think of it as y. Okay. Now, real quick, if I rewrote this and I replaced this with y, that's going to say 3 to the y equals x, correct? So which values, the x or the y values, are going to make it easier for the table? If I take 3 to the y power, it's going to be easier to figure out those pick y values and get the x values, isn't it? Okay, so the values we're going to use every single time, -1, 0, and 1. Okay, so then at that point it's saying 3 to the negative first, 3 to the 0, and 3 to the first. 3 to the negative first, what is that? Alex? 1/3, 3 to the 0. 1. And then 3 to the first? 3. Now, anytime you graph log base 3, that's going to be your table. Because we don't have to worry about name value, right? That's your table every time you use log base 3. So, then again, there's my x column, y column, so right 1/3, down 1, straight right 1, and then right 3, up 1. You just need 3 points. And then again, closer we get, the further we go along asymptote, the closer and closer it's going to be getting. And once we get an H and K value, that's going to shift us left and right, up and down. Okay, so let's just go off to the side here. Log base 2 of x. Okay, so again, either x or y, x and f of x, either way. Your y values is always going to be negative 1, 0, 1. Then again, in this case, we rewrote 2 to the y equals x, right? We're saying 2 to the negative first, 2 to the 0, 2 to the first. So 1/2, 1, 2. Okay, log base 3. It's 3 to the y equals x. xy, negative 1, 0, 1. 1/3, 1, 3. Log base 4. We're saying 4 to the y equals x. Your table, again, negative 1, 0, 1. 1/4, 1, 4. Are you guys seeing a pattern with those tables? Okay, if you're doing negative 1, 0, 1 every time, so just think, you're taking 4 to the negative first is 1/4. 4 to the 0, that should always be 1, shouldn't it? Anything to the 0 power is 1. And 4 to the first is just going to be itself. So if I did log base 5, what would be the x values going down that column? 1/5? 1, 5. If I did log base 6, 1/6. 1/6, right? Log base 7, 1/7, 1/7. Okay. And then from there at the beginning, just figuring out your HK value and then going off of that point, correct? You guys see the pattern with the table? Okay, so my HK value in this case then. Cole?
3, 1.
Are you on the right one? Log base 4 of x?
0,
0, 0. Okay. Cody, what type of asymptote? Vertical. Okay, and log base 4 again. That's just like, you can say 4 to the f of x equals x. Or you can say 4 to the y is equal to x. I don't care what you use. I prefer to use xy. Again, negative 1, 0, 1. Basing, what are those values going down on x? Yep. And again, that's saying right 1/4, down 1. Straight right 1, right 4, up 1. Difference between log base 3 and log base 4. That log base 4 is starting to go right faster, right? Alright, now let's talk about domain and range quick. And then we'll do our asymptotes as well. Domain. Do we go left and right forever? No. So x has to be what in this case? If we're going to the right, it's going to have to be greater than, right? Greater than what? 0. Okay, you're always going to look at your h value. Okay, now range, is that ever going to stop going up and down? No, so our range is not restricted, so y is element of all real. Okay, and then our asymptote, vertical line, is that x equals or y equals? X. And And again, you're just going to use that h value again. Okay, so if I go over to here, okay, we had the same hk value, right? So domain, x is greater than 0. Range, again, is always y is element of all real for logs. Asymptote, same thing in this case. Once we start shifting, then that's going to change, right? Except the range. Questions on those two at all? Okay, those ones are a little more basic, right? Didn't do any type of shift in those ones. Okay, this should say y equals. Okay. Just like any other graph we've done this year, figure out our HK. What is our HK in this case? Spader? 3-1. Okay, got that vertical asymptote going through that HK value, or point I should say. Now that we got that horizontal and vertical shift, do I need to worry about the 3 and the 1 at all, ever? We took care of it with shifting that, right? So then, at this point, x, y, what are the y values I always use? Maria? Okay, and then all you gotta do is look at the base. Or the y equals x. So Megan, what are my values going down for x?
1, 4, 4, and 4.
And we just base those off our HK, correct? So right 1/4, down 1. Straight right 1, right 4, up 1. Ethan, domain in this case? X is greater than 3. Good. Why, again, why is it strictly greater than though? That asymptote, right? We'll never actually reach that point. We'll get really close, but never actually reach it, correct? So it has to be strictly greater than. Range? Drew?
Oh, x is the element of all the reals.
X or Y?
Y.
Y. Asymptote in this case, Matt? X equals 3. Okay, do you notice how those two things line up, domain and the asymptote? Just like when we did exponentials, the range and the asymptote lined up. Okay, so since we have a vertical asymptote, we got to look at that h value. H value will always be part of it. Go ahead, give that last one a try. Notice the base is the same, right? Table will be the same as well. No matter where you shift it. Okay, go ahead, state the domain, range, and asymptote as well. Okay, HK. Mason? Where's our HK value in this case? -2, -3, good. Aubrey, what type of asymptote do I have in this case?
Vertical.
Vertical. And again, it's just the same exact table, isn't it? Same base. And right 1/4, down 1, right 1, right 4, up 1. Domain in this case, Mara? Greater than -2. Range? Hayden? Y is all real. Asymptote? Solvig?
X equals
X equals -2. Not too bad, right? Okay, big thing is those tables. Everyone understand how to get those tables? Alright. Your homework then. 8.4b homework. Find those inverses, graph those functions. Now, real quick, you guys want to do this one real quick? Got a base of 1/2. So go to 74 in your homework. Now, the other thing with this one, what is my HK? Is that -1 your H or K? K. Remember, you will always find H in parentheses, right? So in this case, it is 0, -1. That is the big mistake I typically see with graphing these functions. Look for a parentheses. If there's no parentheses, that value is your K value. And if I have you write an equation, make sure you have parentheses. If I say make sure to, shift left and right however many units, that needs to be in parentheses. Okay, so 0, -1. Okay, now when you do this table, you're saying 1/2 to the y equals x, correct? When I do this table, -1, 0, 1, that doesn't change. But now you're saying 1/2 to the negative first, 1/2 to the 0, and 1/2 to the first, correct? 1/2 to the negative first, what would that be? 2. That's still going to be 1. And this one's 1/2. So when that is a fraction, right? You got to think about those reciprocals, right? So write 2 down 1. Write 1. Write 1/2. Up 1. Okay, so do you see the difference when that base is a fraction? You're approaching your asymptote as we go up now, right? When that when that base was a whole number, we went down and we were getting close to the asymptote. Questions at all from today? All right, you got 10 minutes.